Hi, and welcome to the molar mass of butane mini lab. So in this lab, what you're trying to do is discover the molar mass of butane, which is a gas that's found in most handheld lighters. You're trying to find the molar mass of that gas. And to do that, what you're going to use is you're going to use the PV equals nRT equation to solve for the moles of gas that you release into this graduated cylinder. And then you're going to plug that moles into the moles equals mass over molar mass equation to solve for the mass. Now the molar mass. Now you're going to get the mass of gas that you release into the container here. So if you watch the video, the thing that you will see in the experiment is that the butane sort of is bubbled through water, okay? And so first you start off with a graduated cylinder, it's filled with water, and then you bubble the butane through that graduated cylinder. And as the butane bubbles through, it displaces the water. So now you have a layer of gas at the top, and then you have your liquid water at the bottom. Now, the graduated cylinder will tell you a couple things. First of all, it measures volume. So you're going to use the information here to get the volume of the gas that you have, right? So that'll give you the volume. But what about the pressure of the gas? The pressure of the gas inside of this graduated cylinder is equal to the atmospheric or barometric pressure. So the P of the gas okay? But the thing to remember, though, is that there's more than one gas in here. You have the butane, but since it's over a layer of water, liquid water, some of that liquid water will evaporate. And so you have water vapor in here as well, okay? So that means that the pressure of the water vapor and the butane is equal to the atmospheric pressure. So both of these, so this is P total, which is equal to the P of the H2O plus the P of the butane. All right, so this is sort of allowing you to practice that partial pressures. All right, with that being said, we're going to use the pressure of the atmosphere, which is equal to the total pressure of gas, and the water pressure of the water vapor at the given temperature to figure out the pressure of the butane, and that's going to plug into our PV equals nRT equation. So let's go ahead and start working on the math here. First thing is we're going to just go through and spell out this table. So the mass of butane, we're going to start with that. The mass of the lighter before you emptied it out was 11.50, and the mass of the lighter after was 10.86. So that means that the mass of the butane is going to be 11.50 gram minus 10.86, and that's going to equal 0.64. Okay, the next thing we're going to do is we are going to calculate the pressure of the butane gas. So remember, for that we're going to use the P total, which is the atmospheric pressure, is equal to the pressure of the water plus the pressure of the butane. Now, if we want to solve for the pressure of the butane, we're going to subtract the pressure of the water vapor from both sides. And so the pressure of the butane here is going to then equal the pressure of the atmosphere, or the barometric pressure, minus the pressure of the water. So that's what we need to calculate here. So we're going to take the barometric pressure, 749, and subtract from that the pressure of the water vapor at 23.2 degrees. So 749 minus the 21.3 gives us 727.7 millimeter mercury. Okay, Now we're going to use this value. We want to use it into the PV equals nRT equation, but remember this must be an atmosphere. So to get that into atmosphere, we're going to divide that by 760. So to convert from millimeter mercury to atmosphere, you divide by 760. So we're going to do 7 to 7.7 divided by 760, and that will give us the value in atmosphere, which is 0.9575 atmosphere. Okay, so now let's take a look at the values that we have. We should have all the values to plug into this equation so we can solve for moles. So here's our pressure. We have that. We have the volume of the gas in milliliters. So to convert that to liters, I'm just going to divide that by 1,000. Okay. All right, so now I have the pressure in liters, the volume in liters, and the temperature is 23.2 degrees Celsius, so we need to convert that to Kelvin by adding 273, which gives me a temperature of 23.2 plus 273, gives me 296.2 degrees. Or 296.2 Kelvin. We don't use degree for Kelvin. Okay, so with that being said, I have everything I need. I've got here's my temperature. All right, I can go ahead and plug these in to my PV equals nRT. So let's just rewrite that. PV equals nRT. For my P, it's going to be 0.9. 0.9575. The volume here in liters is 0.09448. My moles will be N, that's my unknown. R is the gas constant, 0.0821. So this number is a constant. You look it up or memorize it. Just make sure that when you look it up, the units for this are liter, atmosphere, per mole, Kelvin. And the reason why it's important is because these units need to match the units for pressure, volume, and temperature that you use. All right, now finally for my temperature, we have 296.2. We're going to multiply these things out. So on this side, I have moles, when I multiply these two numbers, times 24.32. And over here on this side, when I multiply 0.9575 and 0.0948, I get 0.09077. And now what I'm going to do is I am going to divide both sides by the 24.32 to solve for my moles. And I get my moles .00373. And how many significant figures should I be using here for this problem? We're using 3 because I only had 3 for my volume. Okay, so this is there's the number of moles I have here. All right, so now I can take this. I've solved for moles, so that's step 1. I've done that. Now what I want to do is I'm going to use the mole equation in the moles equals moles over molar mass. So I'll use my mole value into that equation. So we have mole is equal to mole over mass over molar mass, not mole over molar mass. All right, so my moles is the 0.0373. My mass of gas is 0.64. And my molar mass here is what I'm looking for. All right, so remember when we have a fraction that is next to an equal sign, we'll use cross multiplication. So I'm just going to put this over 1 to make it a fraction, make it a little bit easier. Cross multiply, and you get 0.00373 times your molar mass is equal to 0.64, and then you divide both sides by 0.0373. And then you get the molar mass to be equal to 171.47. Okay, so that's it in terms of the math. All right, so in terms of what you need to know, we're going to skip question 3 because for your exit tickets, it's not going to help you. But if you are curious, I'll be more than happy to show you how to use this percent error. But what I do want to sort of show you here is how to use this site to get the water vapor, because you need to do that for yours. So remember, we use the water vapor to get the pressure of the gas. So how do you use that site? Okay, so if we go to the molar mass of butane video, this link is the same link that's in your exit ticket for, I think it's question 5 or 6. And it's just to go to this site. So if you open that site, what you will see here is at the top, you're going to put the temperature. Now the temperature of the gas will determine the temperature of the water will determine how much water vapor. If the water is warmer, there's going to be more water vapor because more of it is evaporating into the air. So in our lab, we used the temperature in the lab was 23.2. So go ahead and put that in. Okay, great. And you see the temperature here, 23.2 degrees Celsius. Now here, what I use this just a simplified formula, and that gives you the pressure, the vapor pressure in millimeters mercury. If you wanted to change, you can change the units if you needed to change the units, but I think it's easier just to subtract it if it's in millimeter mercury from the barometric or atmospheric pressure, and then convert that, the pressure of the gas that you have now in millimeters mercury, to your to atmospheres. So I just use, but you can change the units here if you need to, and I just use the simplified formula. All right, I hope you found this helpful. Have a quality day.